Good day, I am Michael Conrad Jibal Corza from VC2B, and I'm here to explain the question 2.10 from the Mechanics of Materials 4th edition. So the given topic is deformation, normal, and shear strain from lesson 8. So let's proceed. Question 2.10, a block of 250 millimeter length and a 50 by 40 millimeter cross section is to support a centric compressive load P. The material to be used is a bronze for which the modulus of elasticity is 95 gigapascal. Determine the largest load that can be applied knowing that the normal stress must not exceed above 80 megapascal and that the decrease in length of the block should be at most 0.12% of its original length. So the given are the length, which is the 250 millimeter, the area, which is 50 by 40 millimeter squared, the modulus of elasticity, which is 95 gigapascal, the allowable normal stress, which is must not exceed above 80 megapascal, and lastly the axial deformation in percentage, which is 0.12%. So as you can see in the question, determine the largest load that can be applied. So we have to solve for the P max. So let's proceed the solution, which is the normal stress formula. So we have given allowable normal stress and an area, so we can use this as a to solve for P. So but we have three more given, so we have to use this axial deformation formula, which is the axial deformation equals to PL over AE. So since we have two formulas, we can gain two answers too. So let's proceed to the normal stress formula. So the allowable normal stress formula, which is the normal stress equals to the load P over A. So we are going to solve for the P, so we have to transpose A to the left side, so we can gain this formula, which is the normal stress times area of equals to P. So by putting all the given, which is the 80 megapascal times 50 by 40 times 1 meter squared over 1 million meter squared equals to P. So we can gain this answer, which is 160 by 10 to the power of 3 Newton. So 160 kilonewton is the load for the allowable normal stress. So let's proceed to the next formula, which is the axial deformation formula, which is the axial deformation equals to load P times length over A area times the modulus of elasticity. So by transposing all the given, the L, A, and E to the left, so we can gain this formula. So as we put all the given, we can gain this, which is this side is the deformation, this side is the area, and this is the modulus of elasticity over the length, which is the 250 times 1 over 1000. So as we calculate this, we can gain 228 by 10 to the power of 3 Newton. So the allowable deformation formula with P is 228 kilonewton. So since we have two different answers, we have to choose the lowest value, so that to ensure that the material will not exceed to the given normal stress and axial deformation.